So, we all like challenges, right? Okay, so here's my challenge. Can I teach the rest of chapter 4 in 10 minutes or less? And for each concept, I have to find a new location within my classroom. Do you think I can do it? And the time starts now. Okay, so types of triangles based on their side lengths. Here we go. First one. Okay, in this triangle, all three sides are congruent. That's called an equilateral triangle. Okay, this triangle, two sides are congruent. That's called an isosceles triangle. And finally, a scalene triangle is a triangle that has sides that are all different lengths. Scalene. All right, let's go find another spot. Ooh, I found something. Okay, so here are some triangles, and we're going to classify these based on their angles. If you look at this triangle, every angle is acute, so this is called an acute triangle. So, acute little triangle. Okay, and then this one has one obtuse angle. Just needs one. You can't have more than one. Or if you have two, then you're already above 180 degrees. So this is an obtuse triangle. So this is an obtuse triangle, a triangle with one obtuse angle. Here, this triangle has one right angle. That's called a right triangle. Right triangle. Okay, and then this one up here, this is also acute. All the angles are the same, and in order for the sum of the angles to be 180, each of these angles has to equal 60 degrees. So technically, this is also acute. But since all the angles are the same, this is called equiangular. And if a triangle is equiangular, it's also equilateral. Okay, let's see what else we can find. Getting there. Ooh, I think I found something. Okay. Okay, so here we have an isosceles triangle and an equilateral triangle, and let's see what we can do. Okay, so let's look at the isosceles triangle first. Okay, we know that two sides are the same, so that means that the opposite angles. Okay, so if we've got 40 degrees, they are all going to, all the angles add up to 180. The sum of all the angles is 180. So like if I call this x and this x, that means x plus 40 equals 180. So I could go 2x plus 40 equals 180. I could subtract 40. And I could say 2x equals 140 divided by 2, x equals 70. So that means each of these is 70 degrees. So the measure of angle A is 70 degrees. Okay, then I have this equilateral triangle, which is also equiangular. So I could go 9x plus 6 plus 9x plus 6 plus 9x plus 6 equals 180. But since we know that each angle is 60 degrees, I could just go 9x plus 6 equals 60, okay, because each angle is 60 degrees. So if I subtract 6, I get 9x equals 54, divide by 9, divide by 9, x equals 6, okay? So I got x equal to 6, okay, but then what I need to do is plug it back in here. So I'm going to put 6 instead of the x here. So 9 times 6 plus 6. So 54 plus 6 is 60 degrees. We already know that the measure of angle 6 is 60 degrees. But we did some fun algebra to get there. Yay. And now we have overlapping triangles. If you look at these triangles, there's a red triangle, triangle ABC, and a blue triangle, triangle EBC. Okay, so red triangle, blue triangle, they're congruent. Okay, do they share any parts? They share like this part of the side and this part of this side. They don't share any full sides. But do you see a part that they do share? Yes, they both share angle C. Okay, if you look at this set of triangles, the red triangle is this triangle QPR, and the blue triangle is triangle QRS. Okay, and so they both share what? Yes, they both share full side QR. And that's all. Good job. Let's go find something else. I wonder how we're doing on time. We're doing okay. Okay. This brings us to our last concept, which is the overlapping triangles proof. Doesn't that sound super fun? Okay, so what you have to do for an overlapping triangles proof, sometimes you have to prove that two different triangles are congruent in order to use CPCTC to find the other triangles that are congruent. Okay, so if you look at this, we're going to prove that triangle MAY is congruent to triangle MHY. And once we look at this, we'll see that we're probably going to prove that this triangle is congruent to this triangle and use some corresponding parts to prove that these other two triangles are congruent. Okay? Okay, so we're going to start with our given statement. So angle 1 is congruent to angle 2. I'm going to mark those. So angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. Okay, so already we can see that on these two triangles, this one here, MAT and MHT, we've got two sets of angles that are congruent. Now, if I look at that, I've got my two parts of two triangles. Now I need to look at a third. And if you look at these two triangles, they share this side, right? I can draw straight lines. Okay, so MT, they share MT. So for my second step, I am going to say that segment MT is congruent to segment MT because it's the same segment, right? So I'm going to say reflexive property. Okay? All right, so next, I have now an angle and a side and an angle of two different triangles. Angle, side, angle. So now I'm going to say that these two triangles are congruent. So now already I can say that triangle MAT is congruent to triangle MHT. And that's because we have angle, side, angle. So that's A, S. Okay. All right? Yay. Okay, so now we need to look. Those aren't the triangles that we're trying to prove congruent. We're trying to prove these two triangles are congruent. So if you look at these two now, okay.
I'll shade this one in brown and this one in red. So you can see the triangles that we're trying to prove congruent.
Okay, so we're trying to prove that these two triangles are congruent. Okay, so we already said that angle 3 is congruent to angle 4, so we have one set of corresponding congruent parts. Okay, do you see something else? Yeah, they share this MY right there. They share that side. So I'm going to say for my next step, And then if you look at these, the original triangles that we proved congruent and these two triangles that we're trying to prove congruent, they have something in common, and that's these two sides. So we can say that MH is congruent to MA, and that's because we had these congruent triangles. So that's corresponding parts of congruent triangles are congruent. So I'm going to say that MA is congruent to MH because of CPCTC. All right, so CPCTC, corresponding parts of congruent triangles are congruent. Okay, and that now we have a side and an angle and a side. So now we can prove the triangle's congruent that we were trying to prove congruent in the beginning. So now I'm going to say that triangle MAY is congruent to triangle MHY. And that's because we have a side and an angle and another side. So that's this. All right, we did it. And that was the final thing we were trying to do. So I don't know, did we make it? Did we make it on the time? Did we make it? Almost. We tried. Good job.